This committee will come to order. Good morning and welcome to the committee's second hearing to examine the systems we have to track the emissions, sequestration, and transport of greenhouse gases in the atmosphere on land and on the oceans. We welcome our witnesses. We'll be having more. This is like a lot of times, it's a busy day, but we're being televised, so some of our members are watching us, and we have our staff here watching here and in the back. And so we want to get all this information down. This is very important. In our first hearing, we examined the greenhouse gas reporting systems and the methods used to verify the information reported to greenhouse gas registries. Today, we will hear about federally sponsored programs to monitor greenhouse gases. Monitoring and verification of greenhouse gases doesn't sound like a very exciting topic. It's a little like housekeeping. It's an essential task that goes unnoticed until it isn't done well or isn't done at all. So without robust monitoring and verification systems, we cannot understand the sources and sinks of greenhouse gases. We cannot detect changes in atmospheric or ocean chemistry or understand the potential impacts of these changes. And we cannot evaluate the effectiveness of policies to control emissions of greenhouse gases. Equally important, we cannot verify compliance with emission reductions agreements. Our nation is a leader in these areas of research. Some of the satellite observations that enable us to track Earth's heat budget are available only because of our investment in science programs at NASA. The ground and satellite observations that we gather tell us a lot about local weather and climate patterns, air quality, and the health of ecosystems and the oceans. The monitoring and measurement systems that we have today serve primarily a research function. Some, such as the monitoring system associated with EPA's acid rain program, serve as a regulatory purpose. We also track emissions to meet our reporting obligations under international agreements, the United Nations Framework Convention on Climate Change and the Montreal Protocol. Our colleagues on Energy and Commerce have begun their work to develop a plan to reduce our nation's greenhouse gas emissions. In December, 192 countries will meet in Copenhagen to forge an international agreement to reduce emissions. We will need a robust monitoring system that is capable of telling us whether we are reducing emissions and meeting our policy goals. And we need to know how the Earth's climate system is responding. Of course, the specific design of the monitoring system will depend upon the type of emissions control policy we ultimately decide upon. We have an excellent panel of witnesses and with us here this morning who will offer constructive suggestions on how we can best utilize the assets we already have in place and make strategic investments where necessary to develop a robust and reliable monitoring system. At a time when warming appears to be accelerating and people are experiencing regional climate impacts already, we need to ensure that we have the information we need on a sustained basis to implement the most effective policies. So thank you all for participating in this important hearing. The chair now recognizes Mr. Hall for an opening statement.
Mr. Chairman, I thank you, and I thank you for holding the hearing here and measuring and verifying greenhouse gas emissions, and I appreciate your leadership on this very, very important topic. While this may not be the most exciting part of the climate change debate the Congress is going to have this year, I truly believe it's one of the most important, and appreciate those of you who have prepared for this, who have traveled for this, and who are giving us your time, because we listen to you because you know more about what we're talking about than we do, and we base the law on what you tell us, the part we believe and understand. So speaking as American as you can, for those of us that aren't physicists or didn't have the great average that most of you had, I wouldn't have liked any of you in college because you ruined the curve for guys like me. But I appreciate you being here. And while, as it's said, it's not the most exciting part of the climate change, but knowing exactly how many pollutants are being emitted into the environment and establishing a verifiable baseline is a requirement for virtually every environmental law our country has ever passed. And without knowing the current state of things, it's impossible for us to truly assess the impact that we're having on the environment, whether that's good or whether it's bad. And if we don't know where we're starting, How can we prove that we've made any progress? Mr. Chairman, you and I both sit on another committee that's focusing heavily on the climate change debate. The entire premise of this debate in the Energy and Commerce Committee is based on the idea that we can accurately measure, we can accurately monitor, and accurately verify greenhouse gas emissions coming from all sectors of the economy. And it's also based on the idea that we can accurately measure, monitor, and verify greenhouse gases removed from the atmosphere through offsets. Setting a cap implies that we know where we currently stand. The trade part implies that we know where it's all coming from. We're betting the entire U.S. economy on the assumption that verifiable data collection and monitoring is as simple as some of the authors say it's going to be. The hearing we're having this morning demonstrates that we do not have these abilities yet. Our witnesses are going to tell us about the need for greater scientific information, about the need for an accurate emission baseline in order to implement any regulatory scheme, about the necessity of developing tools and protocols for verifying sources and sinks of greenhouse gases. The fact that we're still early on in the research and development phase of these methods and monitoring technologies means that we cannot, in good faith, assure the American people that any regulatory framework designed to regulate greenhouse gas emissions based on such methods and technology will not be harmful to the economy. Accurate measurements, verifiable data, and the integrity of methodology are the very things that form the foundation of any regulatory scheme and are the instruments necessary for responsible governance. Albert Einstein once said, and my kids think I knew Albert Einstein, and he wasn't a bad guy. If we knew what we were doing, it would not be called research, would it? Mr. Chairman, I couldn't agree more with Albert. He was a friend of mine, a good guy. Our committee has to continue to be at the forefront of this debate because the work we do here is the groundwork needed by other committees to do their own work. So I have to thank you once again for holding the hearing, Mr. Chairman. I look forward to hearing from these very distinguished witnesses. And I yield back my time, sir.
Thank you, Mr. Hall, and we'll try to get it in Texan so we can both understand it. If there are other members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witnesses. Dr. Alexander MacDonald is the director of the Earth Systems Research Laboratory at the National Oceanic and Atmospheric Administration. Dr. Richard Birdsey is the project leader of the Research Work Unit Climate, Fire, and Carbon Cycle Systems at the Northern Research Station of the U.S. Forest Service and the chair of the Carbon Cycle Scientific Steering Group. Dr. Michael Freilich is the director of the Earth Science Division at NASA. Dr. Diane Kruger is the director of the Climate Change Division in the Office of Atmospheric Programs at EPA. Dr. Patrick Gallagher is the Deputy Director of NIST, and Dr. Albert Heber is the Professor of Agriculture and Biological Engineering at Purdue University and the Science Advisor to the National Air Emissions Monitoring Study. At this point, I would like to recognize my friend from Oregon, Representative David Wu, to introduce our last witness.
Thank you very much, Mr. Chairman. I would like to welcome Dr. Beverly Law for being here today. Dr. Law is a professor of global change forest science at Oregon State University and currently serves as the science chair of the AmeriFlux network and as a member of the science steering groups of the U.S. Carbon Cycle Science Program and the North American Carbon Program. She is also serving on the National Research Council Committee on Methods for Estimating Greenhouse Gases. Her research is on the effects of climate and disturbances on carbon, water, and energy exchange between terrestrial ecosystems and the atmosphere, and methods for integrating observations and modeling to quantify and understand regional carbon balances. Dr. Law has been an author of over 100 journal articles. We welcome you, and we're glad that we could turn out some Oregon weather for all the witnesses today. I yield back the balance of my time, Mr. Chairman.
Thank you, Mr. Wu. And Dr. Law, we hope we'll take it back to Oregon with you. As our witnesses know, we try to limit our oral testimony to 5 minutes, but this is very important. We want to hear from you, and we appreciate your earlier written testimony. And I would encourage you, when this is over, if you have additional thoughts as we prepare. We're on a short track here, and as we prepare legislation, Mr. Hall mentioned that we also serve on Energy and Commerce Committee. And so we'll be a part of it there, but we want to be sure the monitoring is right, and we need your help in doing that. And so your written testimony will be included as a part of the record, and when you have completed your testimony, we'll start questions. Each member will have 5 minutes to answer their questions. And so we will start now with Dr. MacDonald.
Good morning, Chairman Gordon, Ranking Member Hall, and members of the committee. Thank you for inviting me to discuss the key role that NOAA plays in monitoring greenhouse gases and aerosols. Emissions as the result of human activities, particularly of carbon dioxide, are changing the Earth's environment. The unequivocal warming of the atmosphere and ocean, along with increasing ocean acidity, are serious challenges to our future. In addressing this threat, it is important to assess the effectiveness of potential mitigation programs. This will be complex because in addition to fossil fuel emissions, soil and vegetation exchange CO2 with the atmosphere. We are fortunate that our advanced technical civilization has both the tools and expertise needed to implement the monitoring systems we will need. NOAA has decades of experience monitoring greenhouse gases. The current global system for monitoring can be traced back to the 1950s, when the first observations were made at the South Pole in Mauna Loa in Hawaii. NOAA has 6 comprehensive atmospheric observatories and routinely measures greenhouse gases at over 100 sites worldwide with an accuracy of 0.1%. Aircraft, ship, and satellite measurements are also used to get global scale distributions. NOAA and its partners occasionally conduct field programs where they deploy aircraft with sensitive instruments. Here's a picture of our NOAA P3, the Flying Chemistry Lab, measuring aerosols and gases in an experiment conducted over Houston in 2006. NOAA could improve its North American monitoring to provide a check on the success of the mitigation effort. It's helpful to think of greenhouse gases like one thinks about a bank account. The total amount of CO2 in the air, roughly 3 trillion tons, is the equivalent of the bank balance. Emissions increase the balance, which is bad, and when CO2 goes from the atmosphere into the ocean or land, it decreases the amount in the atmospheric bank. So there's 2 ways to check your bank balance. One is to track the income and outgo in your checkbook. Another way is to call the bank and say, how much money do I have? There's also 2 ways to calculate how much CO2 is in the air. First, we could add the emissions, subtract the CO2 going into the land and ocean, and we call this the bottom-up approach. The top-down method would be to simply measure, using our tools, the amount of carbon dioxide in the air. In the mitigation program, it's very important that we do both of these. By carefully tracking total amounts, we can independently check the emissions and tell us whether the mitigation efforts are working. This would also allow us to monitor the progress of the global program and see what other countries are doing. NOAA's Carbon Tracker is a sophisticated computer program that measures the distribution and total amounts of carbon dioxide. On this poster, Carbon Tracker is showing areas of high carbon dioxide in red. You see those in southern U.S., and areas with low amounts in blue. And in this case, the blue is because the air flowed over Siberia and Canada, and the leaves were soaking up the carbon dioxide, so that's why that blue area in northern U.S. is there. Programs like AmeriFlux tell us the biological sources, while fossil fuel emissions give us the human contribution. History shows that accounting through self-reporting is not adequate. Carbon Tracker's top-down estimates are the ideal complement to the bottom-up emissions measurements. In the end, we count on the atmosphere to tell us the complete story. Mitigation will require a more comprehensive program. Our system for monitoring greenhouse gases was designed for research understanding on planetary and continental scales and wasn't designed for the regional scale that we'll need for national mitigation. Fortunately, the system can be enhanced in the coming decade to meet our needs. Our surface networks, our satellites, and things like the Orbiting Carbon Observatory of NASA would give us the horizontal coverage, while aircraft and other instruments could give us the vertical coverage. A robust and complete emissions inventory will need to be implemented by EPA and Department of Agriculture. In conclusion, NOAA has a broad mission to understand and predict the atmosphere and global ocean. We can serve as the honest broker to determine how well our mitigation policies are working and how they can be improved. We look forward to the role NOAA will play in this important endeavor. Thank you.
Thank you, Mr. MacDonald. I agree. NOAA is a very important player in this equation. Dr. Law, you're recognized for 5 minutes.
Okay, Chairman Gordon, Ranking Member Hall, and members of the committee, thank you for inviting me here today to talk about the AmeriFlux network and the potential to quantify fluxes from natural and managed systems in the context of greenhouse gas emissions. The AmeriFlux network has about 90 flux sites currently and has great potential to improve understanding of the carbon cycle and land-based contributions to greenhouse gases. AmeriFlux provides ecosystem-level measurements of the net of ecosystem carbon processes that produce a source or a sink to the atmosphere. The data are used to calibrate remote sensing data and models. Carbon cycle and climate system modelers use flux data to characterize land sources and sinks for carbon and to understand ecosystem responses to climate and land use. So the most effective tool to measure the net carbon fluxes from natural and managed systems is an array of flux sites. The most powerful tool to produce spatial estimates of fluxes from ecosystems is a bottom-up process model that ingests the flux data as well as data from inventories and remote sensing of land characteristics, and this is used to map the carbon stocks and fluxes for every square kilometer. The output of a bottom-up process model could be used to constrain estimates of the terrestrial portion of the observed greenhouse gases. Continuity of AmeriFlux needs to be ensured. The network is built on a model of cooperating investigators, primarily university professors. The AmeriFlux records are now 7 to 15 years in length and are beginning to show long-term trends. AmeriFlux sites are supported by multiple agencies, with the Department of Energy funding about half the sites. I'm in the unique position of heading a regional project that uses observations and models that are going to be discussed today. To develop a sustained and robust carbon monitoring system, I think it's necessary to enhance the AmeriFlux network, intensify the greenhouse gas concentration network, improve crop and forest inventories, ensure continuity of critical remote sensing data, including Landsat and MODIS for the land or bottom-up approach, provide more resources for coordinated data management for assimilation and models, and accelerate data availability and analysis for more comprehensive modeling and assessment. For AmeriFlux, required resources would add sites in underrepresented regions and disturbance classes of forests, add measurements of methane fluxes and isotopes for identifying sources, and add well-calibrated CO2 concentration measurements to augment NOAA's CO2 observations. Additional resources are required for AmeriFlux data management, data processing, and regional to global analysis. The resources needed for a robust monitoring to the system are about the same as that for carbon cycle research. The effective mechanism for communication between academic community and federal agencies are the science steering groups of the North American Carbon Program and the Carbon Cycle Science Program. The NACP is the best organizing mechanism for developing an integrated national network of observations and modeling. The challenge is implementing an integrated national system quickly. Mechanisms for international coordination of infrastructure and analysis could build on the NACP and the new European infrastructure called the International Carbon Observation System. ICOS is a system for carbon monitoring and verification based on observations and modeling of ecosystem fluxes to assess terrestrial sources and sinks, and greenhouse gases to quantify anthropogenic sources. FluxNet is a network of networks, and FluxNet and the FAO Global Terrestrial Observing System could operate within this framework. To ensure that data collected by different nations are comparable, institutional support is required for coordinating observation systems and developing high-quality data systems. In summary, the tools and communication mechanisms exist for monitoring, measuring, and understanding greenhouse gas sources and sinks. Each of the agencies has been working on their piece of the puzzle. Now what is required is a high level of commitment and coordination to build an integrated national system. Thank you.
Thank you, Dr. Law. And Dr. Birdsey, you're recognized for 5 minutes.
Thank you, Mr. Chairman and members of the committee. Thanks for inviting me here. Appreciate the opportunity to talk for a little while about monitoring, measuring, and verifying greenhouse gas emissions. I'll talk a little bit about USDA inventory and monitoring programs, about how they may be used to verify greenhouse gas mitigation activities, and then about some interagency activities we're involved in. First, I want to spend a minute discussing the role of U.S. forests in the climate system. U.S. forests currently take up about 12% of the carbon dioxide emissions from the United States. This is a terrific service that these forests provide. We're not sure how that will evolve in the future, but it's something we want to take a good track of. We want to maintain these forests in a healthy way so that as climate changes, they're adaptable and can continue to provide these ecosystem services. Department of Agriculture has conducted inventories of the land for about 75 years, and we have a network of experimental forests and ranges that have been continuously collecting data for, in some cases, more than 100 years. These information systems are the basis for the U.S. greenhouse gas inventory, the forestry sector, and these inputs are reviewed periodically, and based on these reviews, we do think some improvements are needed. USDA also provides data for land managers to use. We have developed very practical and cost-effective methods for estimating greenhouse gas sources and sinks at the level of farms or forestry projects. So these are very small-scale activities that we provide services to those landowners. We also have developed some user-friendly estimation tools so that private owners and land managers can have a little easier time developing estimates that are specific for their circumstances. Our ground-based observation systems are also essential for detecting the signs of climate change and eventually for monitoring our ability to respond to climate changes. For interagency and academic collaborations, the U.S. Department of Agriculture and the Forest Service works closely with Environmental Protection Agency, NOAA, NASA, DOE, and other agencies and universities to develop the state-of-the-art greenhouse gas inventories. The Carbon Cycle Interagency Working Group coordinates carbon cycle research under the U.S. Climate Change Science Program. I've been associated with this group for something like 8 years. I find it quite fascinating how they are able to bring 10 or more different agencies together to the table periodically to talk about the research that's going on, to do the best job they can to coordinate it, and then go back to their individual agencies and departments and work through those systems. I think it's been very effective. The Carbon Cycle Steering Group that I chair provides input about carbon cycle science and particularly its relevance to the various stakeholder communities so we can assure that the science is meeting the needs of society. We have found that key elements of a national observation network are lacking or at risk of loss, and you're hearing about some of those from the other witnesses today. As I mentioned at the beginning, U.S. forests provide a tremendous service of taking up a large percentage of our greenhouse gas emissions. The future of this is somewhat uncertain. There are many threats to forests, climate change, land use change, fire, insects, and so forth, as well as the opportunity to manage those forests to remain healthy and continue to provide this service. Properly managed forests across all ownerships, public, private, and in urban and rural areas can make a big difference in the future of mitigating and adapting to climate change. These forests in rural areas and communities can really help improve people's lives, and we appreciate the opportunity to discuss the role of monitoring in ensuring that these forests continue to provide those services. Thanks for the opportunity, and I'll be glad to answer any questions that you have.
Thank you. And Dr. Freilich, you're recognized for 5 minutes.
Chairman Gordon, members of the committee, thank you for the opportunity to discuss NASA's greenhouse gas measurements and analysis activities conducted in conjunction with other federal agencies. NASA develops satellites to make global measurements of greenhouse gases and many other environmental quantities. NASA Research and Applied Sciences program, coordinated with other agencies, analyzed spaceborne, aircraft, and ground-based measurements to advance our understanding of greenhouse gases and their impacts on climate. As a result of efforts by NASA and our sister agencies, we know beyond a doubt that nearly half of human CO2 emissions remain in the atmosphere, with the other half removed from the atmosphere into the ocean and the land biosphere. When accumulated over large areas such as boreal forests, these natural exchange processes clearly have considerable impact, but we have much to learn about their details and about how they will evolve as the climate changes. We're measuring aspects of the carbon cycle from space today. Data from the MODIS instruments are used to estimate regional carbon uptake by terrestrial and aquatic vegetation. The AIRS instrument on the Aqua mission and the AURA spacecraft's TESS instrument measure upper air profiles of CO2. However, elucidating air-sea and air-land exchange processes requires accurate CO2 measurements near the surface. This is what the Orbiting Carbon Observatory, OCO, would have accomplished. In February, as you know, NASA's OCO mission crashed due to a launch vehicle failure. OCO would have acquired global, accurate, near-surface measurements of atmospheric carbon dioxide. A comprehensive validation activity was planned and funded using ground-based instrumentation from NASA and auxiliary measurements from NOAA, NSF, and other agencies. OCO would have provided unique global information on spatially extensive, regional-scale natural sources and sinks of carbon. We've been investigating recovery approaches. A team of eminent U.S. and international researchers has assessed the state of carbon cycle science and considered whether a new space mission is warranted now in light of present and planned NASA and international missions. They conclude that an OCO reflight or an equivalent mission will indeed advance carbon cycle science and could provide a basis for thoughtful policy decisions and long-term monitoring. NASA engineering teams in parallel are examining mission options, including a near-identical carbon copy mission and combining a copy of the OCO instrument with a thermal infrared sensor on a single spacecraft to fly in constellation with the Landsat Data Continuity mission. It's our objective to have solid technical and programmatic understandings of both the carbon copy and the combined OCO thermal infrared missions by the end of May. We've also been coordinating with our Japanese colleagues to expand previously planned U.S. validation contributions to their GOSAT Ubuki mission and to utilize data from that mission to test the existing OCO algorithms. The use of the GOSAT measurements, while they can't address all of the science issues that had been planned for OCO, will accelerate the production of quality products from any future NASA mission. U.S. interagency groups like the CCSP Program Office, the Climate Change Technology Program, the U.S. Ocean Action Plan committees, and U.S. GEO, the Group on Earth Observations, coordinate many agency activities. NASA relies on DOE, USDA, NOAA, and other agencies for critical in situ and airborne observations of greenhouse gases and carbon storage in soil and plants. And of course, they rely on NASA for high-quality global remote sensing products to extend the reach and resolution of the existing networks. Together, we've developed vastly improved understanding of the atmosphere and carbon cycle that can now inform climate policy and carbon management approaches. Uncertainties of climate predictions for the 21st century are driven as much by our inability to quantify the feedback between biogeochemical cycles and climate change as by the uncertainty in the physical models of the climate and water vapor feedback or economic projections of fossil fuel emissions. However, sustained, accurate, space-based observations are now improving the science of climate change and enabling better resource management and decision-making. In situ and airborne observations, research activities, and technology advancement are increasing our understanding of the carbon cycle. All of the agencies must continue our collaborations to achieve these ends. The potential benefits are immense. Coupling our present knowledge of emission inventories with new understanding of fluxes will not only support policy development and evaluation, but may also identify areas for mitigation efforts and lower the cost of compliance. Thank you very much.
Thank you, Dr. Freilich. And Ms. Kruger, you're recognized for 5 minutes.
Good morning, Chairman Gordon and members of the committee. Thank you for inviting me to testify this morning about monitoring, measurement, and verification of greenhouse gas emissions. My name is Dina Kruger, and I'm the Director of EPA's Climate Change Division. And my testimony this morning is going to focus on the data that EPA already collects, our national greenhouse gas inventory, the proposed greenhouse gas reporting rule, and our assessment of international reporting programs. I'd like to begin by offering background information about some EPA programs that are relevant to today's topic. We implement successful cap-and-trade programs such as the one for acid rain, which has served as models for greenhouse gas trading. EPA also heads an annual interagency effort to develop and publish the official U.S. inventory of greenhouse gas emissions. And just last month, we issued a proposed rule to establish an economy-wide facility-level reporting system for greenhouse gas emissions. What is common to all of the work that we do is the emphasis on accurate, comprehensive, transparent, and timely monitoring. Simply put, you cannot manage what you do not measure. Moreover, one size does not fit all. The best methods and systems for obtaining high-quality greenhouse gas data must be customized to suit the specific policies we are implementing and the emission sources we are addressing. For example, the monitoring system required to establish baselines and assess progress under a facility-based regulatory program must provide timely and accurate emissions data from each affected facility. Since 1995, under EPA's acid rain trading program, power plants have reported sulfur dioxide emissions measured by continuous monitors in their stacks. Importantly, over the same period, each unit has also reported carbon dioxide data. With power plants representing over 1/3 of the nation's CO2 emissions, we already have a head start on the monitoring program for greenhouse gas emissions. Other large stationary sources could also potentially monitor greenhouse gas emissions, and these additional sources are the primary focus of EPA's proposed greenhouse gas reporting rule, which was signed by Administrator Jackson on March 10th. In this rule, EPA proposes to collect emissions data from entities that emit more than 25,000 metric tons of CO2 equivalent per year. Many emission sources, including many agricultural sources, as well as cars, trucks, homes, and small businesses, would not be subject to monitoring and reporting requirements under our proposed thresholds because of their small size or the complexity or cost of accurately monitoring their emissions. Instead, greenhouse gas emissions from these smaller sources are covered by upstream providers of fossil fuels and industrial gases. EPA estimates that the proposed reporting program would provide baseline data for facilities representing between 85% and 90% of the national greenhouse gas emissions. I would also like to highlight the U.S. National Greenhouse Gas Inventory, which is an annual accounting of all human-caused sources and sinks and provides a means of measuring progress against our national goals. EPA has published this inventory since 1993 in cooperation with numerous federal agencies, including the Departments of Energy, Agriculture, Defense, and State. Given its scope, the national inventory requires a variety of methodological approaches and technologies. Fossil fuel combustion is the source of approximately 80% of our national greenhouse gas emissions, and estimates for this source are accurate to within a few percentage points. In the forest and agriculture sectors, we believe that the data are good, but could be improved through continued coordination between the land agencies, such as USDA, and agencies with remote sensing capabilities, such as NASA and NOAA. Finally, I'll address greenhouse gas monitoring in other countries. We expect the same level of effort and accuracy from other industrialized countries as we have achieved with our own national inventory, and to a large extent our expectations are met. However, there is room for improvement in developing countries, and we have identified three main obstacles to better data. First, reporting requirements for developing countries are inadequate because the reporting is currently too infrequent. Second, government agencies and technical experts in these countries do not receive the sustained support necessary for a strong inventory. And investments in fundamental data such as national statistics in many developing countries are lacking. Third, deforestation and agricultural practices are the primary emission sources in many developing countries, and these are also the most technically difficult sources to monitor. Approaches like remote sensing techniques could be a cost-effective tool to improve land use data in these countries. In conclusion, the greenhouse gas monitoring challenge is complex but solvable. While our primary focus at EPA is on the management of emissions from specific emission sources and projects, we also need to be sure that the reported and verified bottom-up emissions data are representative of what we see in the atmosphere. We may find that our monitoring approaches need to be modified, obtain insights that lead to better policies, or identify additional ways to reduce greenhouse gas emissions. Agencies such as NOAA, NASA, DOE, and USDA are important players in this realm, and a coordinated effort with and among these agencies can achieve the necessary comprehensive top-down understanding. Thank you for the opportunity to speak to the committee today, and I look forward to answering your questions.
Thank you, Ms. Kruger. And Dr. Gallagher.
Good morning, Chairman Gordon and members of the committee. I want to thank you for the opportunity to appear before you today and discuss the National Institute of Standards and Technology's role in interactions with other federal agencies in measuring, monitoring, and verifying greenhouse gas emissions. Today, what I'd like to do is highlight how NIST works with these other agencies to support climate monitoring programs and to measure and verify greenhouse gas emissions. Climate change measurements require high accuracy, excellent comparability, and exceptional stability to meet the stringent requirements for detecting changes in the Earth's climate over very long timescales. Rigorous traceability of measurements to the international system of units called the SI are essential for meeting these requirements and provide a firm scientific basis for policy decisions and to help ensure that our measurements are accepted internationally. The NIST laboratories support other federal agencies that have a primary mission for climate research and monitoring, many of them represented here today with me on the panel. The NIST laboratories provide the measurement science, measurement traceability, the production and dissemination of fundamental data, standards development, and dissemination to support these agencies in their satellite, air, and surface-based measurement programs. By statute, NIST is the National Measurement Institute of the United States, and in this capacity is responsible for the national standards of measurement and for their compatibility within the SI framework with the standards of other nations. To achieve international compatibility in measurement, NIST works with its counterpart agencies in other countries, and NIST advancement, maintenance, and dissemination of base SI units underpins private sector investments in measurement technology and standards, and it provides the means for assessing the quality of measurements. We also provide benchmark references for so-called second and third tier suppliers of measurement services, including private sector test and calibration laboratories, manufacturers of test equipment and control systems, and the businesses that rely on these services and tools. Today, I'd like to illustrate how NIST carries out this role by using two examples. First, NIST has a major role in supporting satellite remote sensing programs by developing the appropriate standards, calibration, and characterization methods, and by creating the tools to analyze measurement uncertainties. This is important not only to the government satellite programs, but also to the commercial satellite industry and various other civilian and government programs. The NIST laboratories possess unique measurement science capabilities, such as specialized laser facilities, radiometers, optical radiation sources that are developed at NIST to tie the measurements performed by the satellites to fundamental standards traceable to the SI units. Current NIST research is lowering the uncertainties on fundamental standards to meet the increasingly stringent measurement requirements for climate research. The requirements for these measurements are directly defined through our collaborations with other agencies and their satellite programs. A second major area of activity at NIST is in the accurate measurement of gas emissions, including greenhouse gases. For over 15 years, NIST has worked closely with the EPA to provide the measurement technologies and measurement traceability to the SI for gas emissions controlled under the Clean Air Act. This includes the Cap and Trade program for industrial sulfur emissions. This program provides measurement traceability to the SI for cylinder gas standards used to calibrate emission stack monitors and works directly with specialty gas suppliers to provide calibrated gases through the NIST Traceable Reference Materials Program. This program has been credited with resulting in a 30% reduction in sulfur dioxide emissions relative to 1980 levels. This experience serves as a useful model for developing greenhouse gas mitigation programs. The ability to accurately measure and verify greenhouse gas emissions is an important foundation for policymakers and regulators charged with the development and implementation of policies. Understanding the measurement technologies required and how they are deployed into the market are key considerations in the establishment of realistic and effective limits. In my written testimony, I've included further details on current capability and on some of the emerging measurement challenges for greenhouse gases and verification programs. Accurate climate change measurements provide confidence in measured and predicted climate change trends and aid the development and assessment of mitigation strategies. The NIST laboratory program is committed to providing the measurement science, traceability data, and standards to support other federal agencies in their climate programs and to ensure that their measurements tie to international standards as needed. We also work with the private sector so that they can provide the needed accurate and traceable measurement services to support any mitigation program. I want to thank you for inviting me to testify today, and I look forward to answering any questions you may have.
Thank you, Mr. Gallagher. And Dr. Heber, when my family gets together on Sundays, oftentimes my daughter and her cousins have to sit at the children's table because it's not big enough for everybody else. We still love them, and we're glad you're here and sorry you had to be pushed off a little bit, but your testimony still is as important as everyone else's, so you're recognized for 5 minutes.
Chairman Gordon, Ranking Member Hall, and other members of this committee, thank you for the opportunity to speak to you about the measurement and mitigation of greenhouse gases from livestock operation. All farms generate various air pollutants to some degree. The big question is how much, and that is not an easy question to answer because on-farm measurements are difficult and costly. Methane comes from enteric fermentation and anaerobic decomposition of manure. Enteric fermentation is primarily derived from beef and dairy cattle in this country. Nitrous oxide is generated directly and indirectly from the nitrogen in livestock manure. Carbon dioxide is produced by anaerobic digestion of manure and animal respiration. Animal agriculture emits only 2.5% of the total United States greenhouse gas emissions, according to a recent EPA report. According to a recent article by Dr. Capper in the Journal of Animal Science, greenhouse gas reductions occur with increased production efficiency. For example, the carbon footprint was reduced by 1/3 since 1944 as milk yield per cow quadrupled. Other reductions occur through methane utilization by anaerobic digesters, good compost management, and applying manure to land agronomically and diet modification. We have much to learn about greenhouse gas emissions from livestock operations, and we do this through laboratory and field studies. The field studies can give us baseline source emission rates, and they allow us to test mitigation strategies. The use of scientific emission models to estimate emissions is the least expensive, but they need to be validated with the expensive field data. While regulatory models have inherent limitations, academic scientific studies can have a great influence on them. The National Air Emission Monitoring Study was funded by the livestock commodity groups. The objectives are to quantify air emissions from livestock production, provide reliable data for developing and validating barn and lagoon emission models, and to promote a national consensus on methods of measuring, calculating, and reporting air emissions in general. The approach of the names is to monitor 38 barns at 15 different sites, and they're monitoring the regulated pollutants, and also at 10 open sources. Overall, 20 farms are involved in this study. Prior studies that we conducted at pork and egg layer facilities are very similar, but they're not as comprehensive as what we're doing in the names. Each barn site, monitoring site, uses state-of-the-art equipment and an instrumentation trailer at the farm. The open source measurements utilize open path laser technology to measure ammonia and other gases. The open paths surround the source. The 20 farms in the National Air Emission Monitoring Study are located throughout the United States and were selected to be representative of other livestock species, or representative of other farms in their respective livestock species. A 2,000-page protocol document was written in 2006 and was approved by the EPA prior to setting up the project. And all sites were set up in 2007, and so the 2-year monitoring effort will be completed by the end of this year. The NAMES infrastructure and the expertise developed by it are a tremendous resource for conducting a similar comprehensive study of emissions of greenhouse gases as recommended in a recent report by the General Accounting Office. Such a study as a follow-on to the NAMES should continue to 1, refine and improve measurement methods, 2, provide data to develop and validate computer models, 3, consider expanding measurements to other farm sources like the land application of manure, which wasn't addressed by the NAMES, and 4, to test mitigation strategies that can reduce greenhouse gas emissions. Thank you.
Thank you, Dr. Hebert. We will now start the questionings, and we will begin with the chair recognizing himself for 5 minutes. Let me, well, first of all, as Mr. Hall pointed out, we wear 2 hats, and we're also on the Energy and Commerce Committee, and we'll be a part of developing some type of a carbon reduction program here for the United States. To be successful, obviously, we have to monitor it. And secondly, I think there needs to be an international component. So let me ask a couple of questions in that regard, quick ones, and then I want to get to a more threshold type question. Dr. Law, you had talked about this FluxNext program in Europe and about how there's use it in terms of modeling. Do they verify that modeling with any type of atmospheric sensors?
The ICOS, the International Carbon Observation System, I think is what you're talking about. And they have very similar components as we have in the North American Carbon Program. So they're both top-down greenhouse gas observations and modeling, and bottom-up inventories and flux sites.
And what is the vehicle for coordination between those agencies in the U.S.?
It's primarily through, right now, through the FAO, Global Terrestrial Observing System, and through the FluxNet network of networks. Flux sites particularly are covered by that. FluxNet, the primary goal of that is to standardize data and to be able to synthesize data.
Are you satisfied that it's doing an adequate job?
I think we need a lot more infrastructure on that. That's been an intermittent type project. It's been on and off again.
Is that European infrastructure?
That's the U.S.
Oh,
So
for our,
US.
okay.
Yeah.
I'm just going to flip through some things.
Sure.
Dr. Kruger, you had mentioned the developing countries and the obvious difficulties there. Is remote sensing, will that be adequate for us to be able to monitor these other countries?
Remote sensing would certainly be very helpful for monitoring what's happening with the issue of deforestation, which is a very important one now in the international context. That would need to be coupled with ground truthing and with a capacity in the country to actually track what's happening.
We'd have to
on
have
the
their
ground as well.
cooperation to do that.
So we do need to have their cooperation, and more broadly, remote sensing does not apply to all the different emission sources that we would be looking at.
And on this same theme, Dr. Gallagher, you talked about it with NIST having to coordinate international standards. Is there a central coordinating body for that?
Well, I think it's happening on several fronts, and it's, so there is a lot of coordination happening with consensus bodies, for example, through the UN and the World Meteorological Organization and so forth, that are coordinating global climate measurements. But what's happening in addition is that the international measurement system, what's called the BIPM, the International Bureau of Weights and Measures, is also beginning to be brought into these questions. And that's the system that ties with national measurement institutes in all of the member countries. And so that's particularly important as measurements need to be pushed into the market.
Okay. Well, I guess here's where I'm getting to. Clearly, there's an international component. International in the sense of undeveloped or non-cooperating countries. Certainly, there is an international component in terms of cooperating countries. Here at this table, you have demonstrated the enormous amount of assets that we have in the country. And so I guess my question is twofold, is do we have adequate assets here? Do we need a separate system? And just as I won't say more importantly, I'm a little concerned about the coordinating aspect of all this, bringing the information together and then being able to have it effectively analyzed. Do we have an adequate coordinating system now in the U.S. and internationally? And if not, what do we need to do for that coordinating system, and what additional assets do we need? And I'll start with whoever wants to start. Okay, yes, sir. Dr. MacDonald.
Congressman, we have a program where we intercompare our carbon measurements, and we work together with the other countries. And you've heard sort of the
You say a program, so what's the coordinating body? Or what's the vehicle for that?
The vehicle is that the standards are all checked against the NOAA standard that we've developed.
But who says meeting come to order? Everybody get started. What's the coordinating body?
I'll have to get back to you on the name of it.
So would you say that we have an adequate coordinating national or international agency?
Yes, we're calibrating against each other.
Okay, so what is that agency?
Well, what we do is we bring the other samples and test them against our NOAA standard. So they've all agreed to do this. So that's how we've been doing it in the past.
But is someone saying, NIST, you're not cooperating? We need to get this over here, or
no, it's a
EPA?
voluntary. It is a voluntary.
And is that going to be, if we're going to bet billions of dollars on a system and raise people's rates,
I think we'll have
and be concerned about our children's future, is that adequate?
No, I think we'll have to improve it, but it's been a cooperative effort so far.
Okay, well, that's what my question is. So is your answer then, no, it's not adequate?
My question is that we have the right kinds of cooperation going on, and that we'll have to basically increase it significantly.
Okay, and so does anybody disagree with that statement, that we need to do more? Okay, so I'm trying, we're getting ready to write some legislation here pretty soon, and I'd like a little, some help in determining, do we have enough assets? How do we coordinate it? What needs to be the body to bring it together, and who needs to coordinate that? Ms. Kruger, EPA has played a role, I think, in trying to synthesize a lot of this information. What is your view?
Well, I would say the perspective that I bring to this is as someone who's really thinking about it from the standpoint of what are specific sources emitting, and how are we managing that and implementing those policies. And I think that my impression is that the coordination that's going on at the scientific level is very robust among all of the agencies. It may need expansion in the policy dimension, because I don't know if the coordination between the scientific research and the policy is as well developed or mature as the coordination on the science side.
Well, I'm getting a little scared here because we're getting ready to make a multi-billion-dollar bet, and again, in our children's future, and in our industry, and in our pocketbook. And so we got to sort of have a little more than faith here. Yes, sir.
Yeah, I'd like to mention again the interagency working group that has done quite well at coordinating the science side of things. And
Is this the North American Carbon?
Well, the North American Carbon Program was an activity that was fostered by the interagency working group, and that program has brought together literally hundreds of scientists from all kinds of disciplines working on methods to bring our assets together. We do have a lot of inventories and remote sensing and sampling and so forth.
So who chairs that?
Well, the chair is rotated among agencies. It's currently co-chaired by USDA and NOAA, I believe. Is that right? NASA. USDA and NASA, sorry.
Okay. Well, we're going to have to do a little more delving now. I don't want to get into my time. The last quick question is, do we have adequate resources now, assets in terms of monitoring, or do we need to authorize more? If you think we're okay, then you don't need to say anything. If we need more, please tell me what it needs to be. Yes, sir.
Well, as you heard in the accumulation of testimony here, within the confines of North America and the continental United States in particular, we have, I believe, an excellent mix of in situ, airborne, and remote sensing. To extend that understanding globally clearly requires additional resources for non-cooperating countries or difficult to get to places. And the unique vantage point of space with broad coverage but high resolution and frequent revisit needs to play a key role there. However, as was pointed out, those measurements are at the limits of our technological ability. We're succeeding at them, but they do require ground truthing, verification, and validation. But that's the basis for a global monitoring system.
So that's something that we need to keep in mind when we go to Copenhagen.
Definitely.
Okay. Unless, did you want to say something? I don't want to take other people's. Okay. This is, again, I would hope that, I know that it's difficult for many of you because you're within an agency and you got to get clearance and you can't be a free agent. But if your brother-in-law has, with your maybe consultation, some suggestions as to how we can set up some type of system, what we need, we would like to have that, and we would like to have that, pretty soon. So, Mr. Hall, you're recognized for 5 minutes.
I would have yielded you more time if you thought you needed it. Dr. Eber, a lot of people are looking to forestry and agriculture as potential sources of carbon credits. Planting trees, switching to no-till farming practices, and some other projects, what they call low-hanging fruit for some of these folks. If you're unable to take direct measurements, how are these reductions verified? And what would this mean in terms of generating offset credits in a mandatory regulatory regime?
I have not studied the methodology for determining those offsets, but I understand that models are used, inventorying of practices, agricultural practices, and so on. Some assumptions are made, but direct measurements can help to refine those methodologies and make them more accurate. That's about how I would answer that question.
Does anybody else care to answer it?
Yeah, I'd like to mention that in practice there are a number of greenhouse gas registries and markets emerging, and many of them have implemented ways to directly measure what's going on the land. They're usually combined with remote sensing and models to provide a more complete picture and a better annual tracking of what's going on. So there is some technology available. There is some concern about the cost of the measurement relative to the value of the credits. And so that is an issue of folks trying to come up with efficient ways to bring these information systems together.
We've had, excuse me, go ahead.
Congressman Hall, I'd like to mention that we have, we actually instrument tall towers like television towers, and we actually measure the amount of CO2 being sucked out of the air by things like soybean crops and so on, so you can actually tell how much is being taken up by some of the plant life.
Well, you know, we've gone through some litigation, and in some areas, particularly in Texas and Oklahoma, and maybe other areas of the country where cities in the proximity of ranches or oil fields or something that the cities felt like had invaded their lakes or their supply of water. You all are familiar with those some of that litigation, I take it. In the interest of litigation, I guess I'm asking this question because their suits are still pending. And a lot of the cities are trying to use against ranches, and they track the Superfund legislation we passed several years ago, because the Superfund legislation has more serious consequences of violation and increases their opportunity to get a better and a more lasting and a more punishing judgment or verdict against the ranches or the oil fields or whatever they say pollutes the cities. Like Waco, Texas, for example, has litigation against the Farm Bureau group the Farm Bureau supported group of farmers and ranchers whose ranches are probably polluting some of their waterways. How would the use of this technology that you all have offset, or how would this affect the emissions profile of the animal feeding operation industry, and how would the cost of this technology compare with the cost of the monitoring technologies? I'll go back to you, if I might, on that, Dr. Heber.
Would you repeat the question about which technology?
I'm not sure I can, but I'll try.
Sorry.
There's been interest on both sides of the Capitol, the concept of poop to power, or the use of I wish you hadn't written that. Use of anaerobic digesters to generate pipeline quality methane. How would the use of the technology affect the emissions profile of the animal feeding operation industry? And how would the cost of this technology compare with the cost of the monitoring technologies?
The anaerobic digestion process affects other pollutants in addition to utilizing the methane and reducing greenhouse gases. It reduces odor, and so it improves the neighborhood nuisance issue. It reduces hydrogen sulfide, which is also a regulated pollutant, and so it also helps the manure handling for the farm, the solid waste management issues. So there's a lot of benefits there, and generates electricity. So there's some revenue available because of the heat and the electricity that can be generated from anaerobic digestion. There is an economy of scale. These anaerobic digesters are typically put on large farms, and now the monitoring of the emissions from an anaerobic digester can be kind of rather expensive. I can't really address how, whether that expense is really too much or not, or whether measurements need to be taken at anaerobic digesters to determine what the emission reductions are, and then those measurements can then be used in models that would then predict the reductions at other sites or for other farms. So I think models, if they're validated by measurements, that may be sufficient rather than requiring monitoring at each one.
Thank you, and I think my time's up.
Thank you, Mr. Hall. And Mr. Wu is recognized.
Thank you very much, Mr. Chairman. I want to ask a couple of narrow technical questions, but first I'd just like to express my concern that we have gone from one era where we have been in almost complete denial that there is a problem to a period when we are charging ahead with doing something about it, and at least consensus amongst many groups that there is a problem out there. And it makes me think of other challenging situations, such as colonial countries that have had their political systems repressed for a very long time, and then all of a sudden they're independent and they're supposed to be self-governing democratic systems. It's not that I question the scope of the environmental challenge in front of us. It's just that looking back on that colonial experience, it's a checkered history about success in going from suppressing certain forms of things and then running them well afterwards. I'm very concerned that we're able to technically manage the systems that we're proposing, and I'd like to get some assurance from you all. Now, none of y'all addressed baseline issues, and if you could discuss the importance of baselines. My understanding is that the Europeans, in not getting baselines quite right, created some issues for themselves, and what each of your groups can contribute to getting accurate baselines so that we can adequately manage what we need to. Dr. Birdsey?
Yeah, thank you. I'll start on it anyways. We do have a National Forest Inventory and a National Resources Inventory that have been monitoring historical trends for quite a number of years, and this certainly gives a baseline for where we've been. I think a lot of the greenhouse gas management systems that are being proposed, however, try to look to the future as to what would happen without taking actions. So here you have to merge the inventory information with very good prognostic models that can pull together different sources of information and make accurate projections. Then you can see how well we have done compared to what was expected.
Are you confident about those forest baselines, and is anybody else confident about any of the other baselines that we would need for the continental United States?
Well, I think the historical baseline record is quite good. I would have less confidence in the projections, actually, because you're dealing with events that are hard to anticipate.
Do the other panelists, Ms. Kruger?
I think one of the primary reasons why we were asked by Congress to undertake the development of the greenhouse gas reporting rule, which we recently proposed, was so that we could have the data that we needed for policy development and the establishment of baselines across the economy. And in the proposal that we've got out for comment right now, we've laid out methods for how we would collect facility-specific information on greenhouse gas emissions across the economy. And that is the kind of information that we would draw on to inform future action. So you're right. When the Europeans tried to were creating their emissions trading system, they had a good national inventory, but they didn't have that data disaggregated down to the facility level, and that caused some problems for them. With the data that we're collecting, and it's our goal to have that data, 2010 data reported to us early in 2011, we're looking forward to having the kinds of information that we'll need to develop the bottom-up policies.
Well, my clock is ticking down now, so perhaps I could rephrase the question of what work do we need going forward to more accurately hone baselines so that they are useful for a regulatory process? Dr. Heap?
On the animal agriculture side, we think that the field studies are needed for having more accurate reporting. And as I indicated in my testimony, we have the technology, and we've been measuring baseline of other air pollutants, and actually greenhouse gas emissions are being added to that network now by the dairy industry.
Dr. Law, a FluxNet perspective, or Dr. Gallagher, a NIST perspective on this?
I think that we need more sites in the Flux network that are in managed systems. So I went through a rundown of that, and we don't have enough sites in early stages of forest development, for example, or after you've thinned forests and watched them recover. We don't have enough measurements there. Again, the sites are used to calibrate models, and once we get that and the remote sensing data, like Landsat goes back to 1972, we can go back and retrospectively look at the trends backwards and then go forward with estimates. In terms of the inventory data, AmeriFlux also measures more of the carbon budget components in ecosystems. So beyond what the Forest Service does, and it would be great if the Forest Inventory Group did add some of those measurements like soil carbon.
Quickly, I guess, I think you said it very well that in terms of policy generation, the more accurate and the more specific information you have, the better off you are. And I think some of this will be a problem of looking at making sure that, baseline measurements are more and more detailed and more accurate. One of the issues we see at NIST as an overriding trend that we're paying attention to is that sort of global average baselines in terms of, large length scales, in other words, averaging over large geographic areas, the status of that is actually quite good. I think one of the issues is where you start pushing to baseline levels, local emission levels at more localized measurements, and how do those get incorporated. And that becomes important if you're looking at points of regulation or other things where you need specific information about greenhouse gas emissions over a sink or over an emission source.
Thank you very much, Mr. Chairman.
Thank you, Mr. Wu. And Mr. Robacher is recognized for 5 minutes.
Recommended for 5 minutes, I was about to say.
That would be hard to do.
First of all, let me ask, how much money is being spent in monitoring these greenhouse gases maybe over the last 10 years? What have we spent? We're talking about billions of dollars? Dr. Heber?
On the animal agriculture side and pertaining to this study that we've done, I would say, well, $500,000 has been put forward by the dairy industry to add greenhouse gases to 5 of the sites. Mm-hmm. And with the limited amount of greenhouse gas measurements that were done by the National Air Emission Monitoring Study itself, I would estimate at least another $500,000, so approximately $1 million.
But I mean, in terms of overall, in our national commitment to studying these greenhouse gases in the atmosphere, I mean, this is really a major commitment of resources, is it not? The answer, I guess, is yes. Let me then, for the record, just put into the record this quotes from maybe 10 various resources that I've talked to. And for example, one quote here is from Dr. Yuri Israel, from who was the director of Global Climate and Ecology Institute and a member of the Russian Academy of Sciences, and was the vice president of the UN IPCC, in which he suggests, and these other quotes are suggesting, that CO2 and these greenhouse gases really do not create global warming and do not change the, basically change the climate, which is what we're talking about. I would imagine that you folks disagree with these assessments of your fellow scientific colleagues. Yeah, yes, the answer is yes. All right. Then maybe what we could, let me just suggest that I'm putting these in the record, Mr. Chairman, for the record of the hearing. If I could submit this now for the record of the hearing, where we have 10 prominent scientists who are in disagreement with the theory that greenhouse gases are.
No objection. And I want to get one thing clarified, is that, Mr. Bucker, you're quoting a Russian scientist.
I certainly am.
And you're betting on this Russian scientist.
I certainly am, along with the other 9 who are American.
I want to get a clarification, because that hasn't been consistent with some of your past actions.
In the past, I have called into question the Russians. That is correct.
Thank you, Mr. Robacher.
Although let me just note that I do recognize that they have a great deal of knowledge about the Arctic and about Greenland and all the rest. So, with that said, would you concede, would this panel concede, that there are prominent members of the scientific community that have offered alternative viewpoints to this idea that greenhouse gases are causing a change in the climate that deserve to be, and their arguments deserve to be addressed? Or is it case closed, debates over, let's spend the money? Come on, here's your chance. The skeptics are just totally irrational, or yeah, maybe they've got some points that need to be addressed. Well, we'll start with Dr. Heber down here.
I'm not an expert in this area in this research area, but I think the skeptics ought to be heard and that their points ought to be addressed.
Yeah, I would like to see a debate on the issue actually before this committee, Mr. Chairman. I'd like to see several people just get up and have, with our participation, just a back and forth, rather than simply, which we have done, is base hearings on the the premise that this is already an accepted truism, and thus what do we need to do now to implement policy? I would suggest that this country is about to spend hundreds of billions of dollars on policies that are based on premises that have not been proven scientifically. And please feel free to disagree with me, and if not, I would yield back the balance of my time.
Thank you, Mr. Robacher. We had a skeptic today to had an opportunity. We have had those discussions here, and again, I think it's valid that we continue to look for skeptics to keep us honest. But the fact of the matter is, over 170 nations, including the United States, certified by President Bush, confirmed that we do have global warming with 100% certainty, and within 90 or 95% certainty that it is a direct result of human activity. Clearly, we need to continue to ask the questions, but I think that we have enough consensus that we need to move forward. But you serve a constructive part by making us continue to rethink. And let's see, Ms. Dalkemper, I believe you're next.
Mine's not working. I'll use yours. Thank you. Thank you, Mr. Chairman. According to an article in the October 08 issue of EOS, deforestation and forest degradation account for about 7 to 30% of total anthropogenic carbon emissions. How well do we really understand the emissions from deforestation and degradation, and how much research is being done on the ways that we estimate these emissions from deforestation? I'll open this up to the panel, whoever would like to answer this. Anyway, Dr. Birdsey?
I'll take a start at it. You're interested globally in these estimates, right? Mm-hmm. Yeah. I think over the years, with the continuation of the remote sensing programs, we've learned a lot about the rate of deforestation in countries of the globe where we didn't know much about that before. But there is quite a bit more difficulty in monitoring and estimating the impact of forest degradation because this is a lot more subtle process. Land is not being cleared and put into some other use, but rather some part of the growing stock or the biomass is being removed. And when you're taking a smaller portion of that out, it's not quite as detectable from space. So we know part of the answer, but the degradation part, I think, really needs quite a bit more work.
Does any agency have the lead in this type of work?
I don't think it's a U.S. agency. Really, the Food and Agriculture Organization of the United Nations has really worked on this over the decades more than anyone, and so they've tried to organize reporting by the individual countries and tried to build up the capacity of individual countries to make their own estimates. They've done some independent work looking at remote sensing globally, but I don't believe that's evolved into a robust system yet.
Would anyone else like to address it? Dr. Freilich?
Yes, to put some numbers on your assertion, if I can remember correctly from the last papers that I read, based on satellite measurements as well as modeling and in situ analyses over several decades, I think the estimate is that we as a species have put about 300 billion tons of carbon into the atmosphere from burning fossil fuels. and that there have been about another 160 billion tons of carbon excess put into the atmosphere through land use and land use changes in the industrial era. So those are relatively precise numbers that come from pretty sophisticated analyses of a whole wide range of global data, including the remote sensing data.
Thank you. My other question really has, Dr. Birdsey, you indicated that key elements of a national observation network are lacking, and I would ask you to maybe expand on this, and of the major gaps in our national observation network, what 2 or 3 are particularly important to fill?
Yeah, thank you. Well, on the land side, our inventories are fairly comprehensive, but as Dr. Law mentioned, we're not capturing changes in forest soils as well as we should, and there are some parts of the country, like Alaska, where our inventory systems are not as intense as they should be. That is, the sampling intensity is not as good as it should be. So those are a couple of areas on the land side. We are concerned about the continuity of some of our observation systems. AmeriFlux, for example, is funded on an individual site basis, and sometimes they come and go, as one example. Our atmospheric monitoring system, looking at direct measurements of the concentration of carbon dioxide in the atmosphere, shows great promise, but it's a very sparse system, so they're unable to resolve fluxes at a very small scale. Those are the few that come to mind.
So if you were going to prioritize the gaps that need to be filled, number 1, number 2 would be?
Well, coming from the Forest Service, I'd like to see the land inventories beefed up a little bit, but I would also associate that with FluxNet. I think that would give us a really robust picture of what's going on the land. The second area would probably be in measuring atmospheric CO2 concentrations.
Okay, thank you. I yield back.
And Dr. Braun is recognized for 5 minutes.
Thank you, Mr. Chairman. Panel, I'm a scientist. I'm an applied scientist. I'm a physician. And I believe in science. I believe in scientific integrity. And I believe when Mr. Rohrbach asked you all a question, the answer of silence was deafening, except for from one individual, and that's Dr. Eber. And I must say that I'm extremely disappointed. I think y'all have absolutely zero scientific integrity because y'all have drank the Kool-Aid and have decided absolutely this belief process that human-induced global warming is absolutely a fact. And I disagree with the chairman, respectfully so, that, and our former president. He was misled. He was wrong. You're wrong. There is a tremendous panel of 1,000 or more scientists around the world that disagree with human-induced global warming. My question to each of y'all, are y'all absolutely bound and determined to shut down the economy, create massive job losses, create a huge increase in the cost of food, medicine, all goods and services in this country to pursue an agenda, a political agenda that has absolutely no scientific consensus that there is human-induced global warming? And I'd like each of you to answer just yes or no. Are you bound and determined to pursue this human-induced global warming idea that has no scientific consensus? Yes or no? We'll start with Dr. Eber.
I would say no. And I applaud EPA for negotiating with the livestock industries to get the science before regulation on the Clean Air Act pollutants and also the CERCLA and EPCRA pollutants. Make sure the science is there first before proceeding with regulations. Because
Amen.
regulations can get ahead of the science. And I think it's important to get the science, and even if we have to wait.
Dr. Gallagher just wrote yes or no. No.
Our position in this is we're ready to carry out the policies that are needed and to support them with good measurements. We're really not a climate change agency, and as a scientist, I have to say that there's a strong preponderance of evidence that there are climatic effects associated with the gases, and that seems to be what we see in the policy.
Well, there are a lot of other theories about that, in fact, that have just as much data as human-induced global warming. And in fact, we've had global cooling over the last almost decade now, and a volcano creates as much CO2 emissions as every human being in the world. Yes or no?
Yes, I believe that we do need to act to deal with the threat of climate change, but I don't believe that doing that needs to jeopardize our economic growth.
It's going to. Yes or no?
I agree that we do need to act. The data are clear. The preponderance of evidence is in favor of human-induced global warming. I agree with Ms. Kruger that getting ahead of this issue will, in fact, be good for this country as opposed to shutting down the economy.
Well, I'm about out of my time, but I want to reiterate. Y'all have shown me you have no scientific integrity because you do not consider the skeptics and the other folks. You've drank the Kool-Aid. And I just ask you, in fact, the Secretary of Energy was here, and I asked him the same question about shutting down the economy. This administration seems bent on shutting down our economy to pursue something that has no scientific consensus and no scientific, really no scientific basis. It's a theory, it's a belief system, it's a religion with you guys, and you're totally wrong. And with that, Mr. Chairman, I'll yield back.
I thank the gentleman. I would just encourage panelists to be respectful of our panel and to avoid concluding that because someone disagrees with you that they have no integrity and you do. This is a committee that respects diversity of opinion, and in this case it's not just opinion, it is also scientific evidence. And questions of integrity, we try to refrain from impugning the integrity of our colleagues here. I would just urge panel members to show the similar respect for our witnesses. With that, I'll recognize Ms. Dahlkemper. Sorry, Mr. Lipinski.
Thank you, Mr. Chairman. I want to get back to the issue at hand in terms of measurement. There are a lot of debates going on right now about what to do about global climate change, and the two general categories of ways of addressing it right now that are being discussed here in Congress are going with some type of cap and trade system, or some type of tax or user fee, whatever you would like to call it. Does either one of these require a greater degree of certainty in terms of measurement than the other one does? That is, what we know, what we can measure right now, what we have available. Does either of these two systems in general require more or less? Can we get away with less measurement accuracy with one rather than another? I just want to throw that general question out there. Ms. Kruger.
I think you're asking a very good question, and I think that that actually whether one were to do a cap and trade program or a tax, you would still need to measure the emissions accurately from the facilities or the entities that you're placing that tax on. So from the standpoint of the facility level or those bottom-up measurements, you would need a very similar type of measurement approach, whether that's continuous emission monitors or other means of measuring the emissions. In a cap and trade system, you may have other types of policies that come along with it, like offset policies that might not be part of a tax, and so there might be some things that wouldn't be done under a tax. But the fundamental measurement to determine what the amount of the tax is going to be is very similar to what you would need to do to determine compliance with a cap.
Anyone else agree with that then? Dr. MacDonald?
Yes, I agree. Fundamentally, from the top-down viewpoint, both of these would require a very similar monitoring system.
Dr. Birdsey?
Yeah, I'd like to mention just that the details of the program are not independent of the monitoring system, or maybe I should say vice versa. I completely agree that considering the cost of monitoring needs to be part of the consideration of the program. And some of those details may or may not increase the cost. For example, if you're looking at estimating a change in or emissions or sequestration in forests, and you want to separate out the effect of a human action from some natural variability in climate or wildfire and so forth, it may cost more to do that separation than simply to look at the total change. So there's ways the rules, the way the rules are written may affect the cost of the monitoring. So it's important to keep that in mind.
I want to ask, for following up, Ms. Kruger, the reporting rule, as you say in your testimony, does not establish protocols for offset projects. What would have to be, what kind of research projects would be needed to address the monitoring challenges of the offsets?
Well, I think if we were developing an approach like this for offsets, we would approach it the way that we did when we started working on the reporting rule. That is, there are a number of monitoring protocols that have been developed in voluntary markets dealing with a wide range of possible offset sources. We've done that at EPA under our Climate Leaders program, but there are many others, and you would basically want to look at what's been done out there, take the lessons from that, and use that to establish the types of monitoring protocols that would be needed. This would need to be supplemented, I think, particularly in the agriculture and forestry area, with some additional policy considerations around whether the actions are additional and what happens if there's leakage or reversals. But broadly, we would draw on a lot of good information that's been developed already.
Thank you. I want to thank all of you for your testimony. It's a difficult position because we're here today, you are here today to talk about measurement and the bigger question of what we are going to do about global climate change is sort of a separate issue, those policies, but it all comes down to the ability to measure as accurately as possible emissions, offsets, and so it's critical that we get that right in order to be able to have a policy that can work. So, yield back. Thank you, Mr. Chairman.
Thank you. Recognize Mr. Bilbray for 5 minutes.
Thank you, Mr. Chairman. My question is, traditionally, we've used air indexing as an indication of traditional emissions, basically a paper chase in the United States, in North America, and in Europe. What is the credibility of our emissions measurement at this time in the third world? Anybody want to talk about how do you go down into Nicaragua right now and determine what is the emissions coming up off of Nicaragua right now? Go ahead.
Congressman, one thing we can do is with both our satellite assets and our aircraft assets, you can actually get estimates of the total amount of greenhouse gases coming off of a country by measurements that you take offshore and around it and at our observatory. So you get some estimate of what the source is.
Because in third world, right now, this is the season where they're burning off half the forest right now. Anybody who flies over Latin America right now will see the fires going off. My biggest concern is that traditionally we've always based it on the paper chase because it's like if it isn't filed, it isn't there. China is, you know, when we're facing areas like China and India. In fact, last report I saw, China's increase last year was more than the total emissions of India. How do we monitor that kind, where you end up having not only the massive industrial but also the urban practices that may be a massive increase in emissions? Everything from the way they raise their poultry, to the fact of the way they handle their livestock totally, to their ag uses. How do we monitor it in places like China and India?
Congressman, there's a similar answer. You know, we had this problem in the 50s where we tried to monitor if there were nuclear bombs, and we'd actually measure the flow of various carbon isotopes. When we make measurements, both with our satellite assets and out over the ocean, we can actually determine how much the gases are in these quantities and at our observatories. And I think you're right that it is it's not a very precise measurement, but it does give us an estimate of what they're doing.
Yeah. Anybody comment about that challenge? Because let me tell you something. I worked with cap and trade in California, and I know the committee gets sick and tired of hearing about my air resources background, but I was a big supporter of cap and trade when it could be actually monitored. What scares me to death, and I see a huge potential for corruption, and when we start going overseas with a cap and trade, to where the monitoring and accountability, that there will be a teak forest that was grown anyways, was going to be cut down, all at once becomes part of a SYNC program, and the ability to account for this scares me to death. I just think there are people out there looking to make a fortune off this. And I'll say this to the chairman, mark the words. We go into an international cap and trade, the scandal of what the diversion of funds and the way this is being hit is going to be a big one. So I'll raise that. And let me just say to my colleagues that are frustrated at some of our colleagues attacking you guys about the whole concept of the climate change issue. My real concern is based on ice core samples. I'm just looking at historical levels from ice core samples. I work with my Scripps guys on that. But the problem is the credibility of the whole climate change issue is really hurt when the same people that are screaming that the world is coming to an end and that we must do extraordinary things to save the planet will not even stand up and say that the federal government's subsidy of corn ethanol is not only not solving the problem. In fact, the latest report from Duke University is it'd be better to burn regular gasoline than to do what we're doing with corn ethanol. You know, that's the kind of thing that comes down. When the State Air Resources Board Duke said it's better never to plant the crop. The California Air Resources scientists, the best in the world, said that it's better to burn regular gasoline than ethanol, but this town continues to subsidize it. Under what justification? That we care about the planet? Our whole credibility is being destroyed. So when you see someone like Dana Rohrabacher throwing a fit, his argument is if you really cared about the planet, you'd be taking on the corn industry. You would be willing to stand up for next generation nuclear, but you're not willing to take the heat to do that needs to address the problem that you're claiming around. And so actions do not reflect the concerns. And that's the credibility problem we have here. I apologize, Mr. Chairman, but every chance to be able to rattle a cage, you know, I'll do it. Thank you.
We do know that, and I would only point out that articles in Science Magazine and Nature and others have addressed precisely the gentleman's point. So it is not at all that the science community has been silent on this. They actually have spoken about it. Oh, then don't take it out on these folks. Take it out on our folks. I'll recognize myself for 5 minutes. Thank the panel. Two major issues for me are forests and oceans. Dr. Birdsey, when you were asked earlier by Ms. Dahlkemper about the lack of monitoring, I would have added to that the CO2 in the oceans. While the skeptics can talk about climate change, to be skeptical about ocean acidification is to be skeptical about chemistry. This is an abstract computer modeling. This is CO2 goes in water, makes carbonic acid. Carbonic acid makes the minerals less available minerals means coral die. You can do that. It has been done. It's been replicated. It's been tested in a number of ways. And I hope you can talk a little bit about monitoring in the oceans. I have the belief that that satellite that went into the oceans instead of the atmosphere was trying to tell us something. The second issue is forestry. So I'm going to put that out there and ask the panel in a second to talk about. The second issue is forestry. The renewable fuel standard and the new legislation being debated elsewhere in this building at this moment prohibits the use of fuels from federal forests as part of biomass that would be subsidized. I think that's a terrible mistake. The dead trees and dying trees, we have 1 million acres of forest that need treatment in the Pacific Northwest. If you don't take those trees out, they're going to become carbon because they're going to burn or going to be eaten by insects. And yet we have, in the name of the environment, proscribed using this wood for a fuel source. I don't get it. If somebody can tell me scientifically why that is the case, I'd sure welcome that. So let me put those two things on the table and open it up.
Yeah, first I'll respond a little bit about the question about monitoring oceans. I'm not an expert on the oceans. I work with trees, so I'm a little bit outside my area here, but as chair of the Carbon Cycle Science Steering Group, I do hear about oceans, and I can report a little bit about what that community has said. Everything we've said about continuity of satellites and the need to continue to improve the spectral resolution of those sensors applies to the oceans as well as the land. And so I hear a lot about the need to do a better job of sensing ocean color, for example, which indicates a lot about the biological activity there. I think the other part on the ocean side is there is not a very coordinated or sustained, I should say, system of direct observations. It's just a little harder to get out there. You know, there's no roads and so forth, and so to actually confirm the satellite observations with direct measurements is much more difficult in the oceans, and so I believe that's an important component that needs to be added.
Given that they take up 25% of the carbon and that a great portion of our oxygen is produced by the oceans, we got problems here with that lack of data.
Yeah, I agree.
Dr. MacDonald?
I'd like to agree with your comment. The CO2 going to the ocean is a simple process. It does create acid, and we do go out on the ocean in NOAA with our ships and have made literally thousands of measurements, and it's very clear the ocean is becoming more acidic, and it really is almost a completely independent problem associated with the release of CO2.
Would someone like to address the forest issue? Because this is a critical, Dr. Freilich, if you wanted to talk about the ocean some more, that's fine too, but I'd sure like the forest issue addressed as well.
I'll just say one word. As an oceanographer by training, I don't know much about forests, and I do know a little bit about the ocean. You mentioned some of the direct measurements and the validation, and in fact, there was a joint NASA-NOAA field campaign to the Southern Ocean, which is a huge expanse, which is very difficult to get to, has very high winds and large gas transfer rates. And it was a very successful experiment just about a year ago, which actually pinned down some of the key transfer rates. And this, coupled with satellite measurements such as we hope to get, will actually open up those huge areas to calculation.
Someone address the forest issue, please.
I'll get started on that. Obviously, there's a lot of natural disturbances taking place in the forest, wildfire, insects, and so forth. If you go into the Rocky Mountains, vast areas of dead trees are visible.
Go in the Cascades, it's the same.
Yeah, and so it would be essential, I think. I didn't mention this in my previous response about some of the things that are needed, but some more direct measurement of impacts of these disturbances as they occur or right after they occur would be very useful to providing a much more accurate annual estimate of emissions from forests from these disturbances. But perhaps more important would be to understand a little bit more what's going to happen to these lands in the future. How fast are those standing dead trees, for example, how fast are they going to decompose? What happens when they hit the ground? What's going to regenerate on those lands? How fast will it regrow?
Let me ask you a simple question because I'm out of time. would it be better to let them burn in a forest fire, or to use them to sink them in the form of a house, or to use them, at least if you're going to burn them, to create energy as an alternative to coal?
It's clearly better to make some use of that dead material rather than let it simply decompose and add CO2 to the atmosphere.
Thank you. Mr. Tonko.
Yes, just briefly.
Actually, recognized for 5 minutes.
Okay. Thank you. I wasn't here for the start of the interaction with the panel and the committee, so forgive me if it's been asked. But I think, for clarification's sake, it's important. First, let me thank you for your professionalism and for your willingness to contribute to what is a very important dialogue. There are a number of groups independently from the scientific community and federal agencies that get into data collection. And the ground-based and space-based information feed, the data that are collected, are important, I think, to developing policy. Is there this structural concept that consolidates and coordinates all of the work done, the data collection, in a way that can drive the most meaningful policy response? I think that's critical to a sound outcome.
Well, we talked earlier that there's an interagency working group that tries to coordinate the activities of 10 or so different federal agencies, all of which collect data in some fashion or manage the data and so forth. But in the end, a lot of that goes back to the individual agencies and departments to manage those programs. In fact, many of those programs, like the forest inventory that I'm most familiar with, is there anyways. It wasn't set up for a climate change type of program. It was set up for a lot of other purposes, to assess the status of the forests in our country, to keep track of the changes and so forth. But that data has become essential as a baseline for understanding what's happened, for beginning to take a look into the future as where these forests are going, and you need that information to design the policies.
And is there a connection to the scientific community, or is it just work done within an agency or a group of agencies that's feeding that system?
I think it's really very well integrated among the scientific community. Many of the users, if not the majority of the users, are from universities or private institutions, companies and so forth. So these data systems are very widely used.
Are there improvements any of you could cite in terms of data collection and consolidation? Yes, sir. Dr. MacDonald.
I think that our existing systems a lot were designed for scientific reasons, to understand what was happening. I think a mitigation regulatory regime will require probably a denser resolution. It'll require more surface ops and actual measurements. So we're using them for a more extensive purpose, and it'll probably require additional capabilities.
Dr. Law, were you going to comment on it?
Yeah, I was going to say the same thing, is that there'll need to be more of a density of measurements and more comprehensive data system. Right now we have several databases, and we need a good connection between data streams and the final product.
Is there like an example, a dynamic that you could cite for us that would reinforce that thinking?
I guess I would say with the North American Carbon Program, a lot of the activity that's going on there right now is bringing all of this information together to feed into the models.
Yes, Ms. Kruger.
I think from the perspective of implementing a policy, we do have the measuring and monitoring technologies that we need to be confident in what we see happening, say, at a power plant or at an industrial facility. The new dimension to this discussion is to connect this now up to the scientific verification that's being done through the atmospheric measurements. I guess the scientists talk about ground truthing, and I sort of think about it as sky truthing. So is our policy, are our policies in an aggregate way having the intended result? And if we see things that surprise us, or we don't see the results that we were expecting, then we need to dig in and figure out why. Is it something that needs to happen in terms of the monitoring technologies we're using? Is there some interaction that we're missing that needs to be dealt with? And so I agree with the comments of the others on the panel that more monitoring stations, more spatial disaggregation, more frequent monitoring, so that we can get a better picture from the atmospheric side to be able to reconcile with what we're seeing at the very bottom up at the facility side will be helpful to this process that we need to engage in going forward.
We've been asked for a second round of questions, and I'll now thank the gentleman from New York. We'll recognize the gentleman from Texas, Mr. Hull.
Yeah, I'll be very brief because I'm supposed to be somewhere right now. All of us have about 4 committees that we're trying to attend. Mr. Chairman,
You are somewhere right now.
I am somewhere right now. I won't ask you a question and ask you for a yes or no answer, because that's very difficult. And I know that you're here and we're asked to beef your memories up on that you're knowledgeable about, and that's monitoring, measuring, and verifying greenhouse gases. And that's what we asked you to come here and testify to, and that's what you have testified to, and I appreciate that. But I'm going to make a presumption here that all of you have either been in a store, a Sears, a Walmart, a Kmart, Walgreens. Any of you that haven't been in some of those stores, almost all of you have, haven't you? And I don't know much about forests or oceans. And Mr. Chairman, I know a story about an old man about my age that had applied for a job cutting timber with a company, and they asked him for a background. He said, well, he worked for the Sahara Forest Company. He said, well, Sahara's a desert. He said, yeah, it is now. That's not...
we don't get our fire policy right, Mr.
So I know nothing about forest or oceans, but I do know about...
Texas has neither, I noticed.
About cash registers. And I want to ask you about a cash register, because that's very important. Each of you are probably pretty huge taxpayers. And as such, you know that the government has a cash register, and you send in the 15th of April every year, and we're all affected by that. I just want to ask you if you'll do this. As you go down through your testimony, as you go down making a decision on the future direction that we ought to go in the global warming thrust, is that you remember that there's a cash register, and that somebody's got to pay, and remember that there are costs involved in it, and remember that there are taxes involved in it. It's the way the government extracts its money to pursue something like this, that you will certainly know that if we don't have help from China, Russia, Mexico, India, and go on, that we can't cleanse the world. And I just ask you to take all that into consideration and remember that there is a giant thing there, is you can't get out of any of those stores without going by that cash register. And that's what this nation's got to do, not to endanger the economy or have generational theft from youngsters not even born yet by putting taxes upon them, that you consider that. That's all I ask. You're good Americans, and you care about this country, and you cared enough to come give your time today. I just want to ask you to remember that. Mr. Chairman, I yield back my time.
I thank the gentleman. I'll recognize myself for 5 minutes. Could you talk briefly about the percentage, very briefly, what's the percentage of CO2 put out, global CO2 put out by the United States of America at present? Anthropogenic.
I don't have the exact percentage for you, but it's on the order of 20%.
And we're about what percentage of the world's population? 3.
3.
I think 3 to 5. I mean, you can quibble a little bit. So we're a small percentage of the population. We produce a large percentage of the greenhouse gases. To follow up on Mr. Hall's observations, if there is accuracy that ocean acidification and overheating of the climate are occurring, what are the economic costs to the next generation of that if we don't keep that in check? Any thoughts about that? We got to get some economists next. My wife's an economist. She'll whack me over the head and say, get an economist there. They'll talk about that. Ms. Kruger?
I'm not an economist. I'm not a scientist either, so I'm not going to.
You're perfect.
Say whatever I want.
Not getting much from the scientists here, so
yeah. What I would say is there is an enormous amount of work underway in the economic community, coordinating with the scientific community to try to understand the costs of various climate change impacts, including the impacts of ocean acidification on coral reefs, and in terms of both the ecosystems and tourism and the like, but looking across the broad range. And I think it's a very complicated and challenging topic, because some of these costs can be readily monetized and other things are much more difficult to put a value on. But there's a major effort underway in the economic community to tackle that.
Given the topic of the hearing about monitoring of anthropogenic CO2, or not just anthropogenic really, but in your scientific judgment, do we have sufficient evidence of a linkage between anthropogenic CO2 and increase in CO2 in the atmosphere? Let's take that first. Let's set the temperature change aside and the acidification change aside. Is there a link between anthropogenic CO2 and global atmosphere? Just quick yes or no, round that down the line.
Yes.
Yes.
Yes. Yes.
Yes.
This is not my area, but I am skeptical, as I indicated earlier.
Meaning you don't think that the historical measurements of CO2, atmospheric CO2 concentrations, suggest that there's any relationship to all this fossil fuel we've been burning and the concentration of CO2 in the atmosphere change. Let us set aside temperature change, just CO2.
Right. I am skeptical that there is sufficient evidence to absolutely conclude that that CO2 production from human activities has created that significant amount of increase in CO2. There are other effects, such as volcanoes, et cetera, and natural cycles.
Okay. Do you believe that there has been an increase in CO2 based on historical monitoring?
I am not an expert in studying ice cores and that sort of thing, but I understand that there has been an increase in CO2 in recent years since it's been measured.
Okay. Do you believe that the burning of fossil fuels creates CO2?
Yes.
Do you believe we burn a lot of fossil fuels?
Yes.
Do you believe that produces a lot of CO2?
Yes.
And where do you think it goes?
It goes into the atmosphere.
Okay. And the ocean, apparently 25% roughly.
And some of it's used by plants.
Yeah, no question about that. If we look at the monitoring process, we actually had a hearing a few weeks back that suggested there is enough ambiguity that might make a cap-and-trade system somewhat difficult to monitor, even domestically. Certainly the non-point source. If you look at, we've got some mechanisms to monitor coal plants, for example, but it's much more difficult to track at the pump or the tailpipe, those. Is there any reason, I'll defer. The question would run us into far more time. The question I was going to ask is, there's a lot of folks in this town wedded to cap and trade. I think there's legitimate argument that the complexities of a cap and trade system, along the lines of what Mr. Bilbray presented, might cause us to suggest that a carbon tax is more elegant, more efficient, more defensible in many ways economically, but I'll leave that. Mr. Rohrabacher is recognized for 5 minutes.
Thank you, Mr. Chairman. What percentage of the atmosphere, of the air, what percentage of that is CO2? Come on, we got the experts here. What percentage of the air is CO2?
Approximately 21%.
21% of the air is CO2.
No, that's not
CO2
correct.
is approximately around 400 ppm, which is around, what?
0.03.
0.03%.
Oh.
0.03?
So it's not 20%, it's what was that? 0.03% of what we're studying is CO2.
Mr. Gallagher, you were talking about oxygen, weren't you? Okay.
All right. Now,
O2.
yeah, CO2, okay. Of that CO2, how much of that, now we keep hearing this other 20% figure that the United States is responsible for 20% of the CO2. Well, that really isn't the case, is it? Of the CO2, that's 20% of the man-made CO2, correct? And how much of that 0.03% of that, how much of that is man-made?
About a third of it.
A third.
Congressman.
Okay.
So we started.
Do we agree? Does that agree with the panel? That's a lot higher than anything. I've been through many hearings like this. The biggest thing I've ever heard is 5 to 10%. You're saying it's gone up to 30%. Is that right?
Congressman, we started at 280 when we started putting industrial gases in, and we're now at 385. So it's approximately a third.
So the panel agrees with that? A third of all the CO2 that's being put into the atmosphere comes from human sources. Is that agreed? Does it agree with that? Okay, so I don't hear any. What about you? Do you agree with that? Okay. That is contrary. Let me just note that that is contrary to what has been testified before this committee on several occasions by other scientists. So it's 1/3 of the 0.03. So you say 0.01 is what human beings are contributing to this. Is that what you're saying? Is that right?
Yes, sir.
Okay. And 0.01, and of that, 20% of that is Americans' contribution of that. That would be, it's minuscule, ultra minuscule, and the changes that you would expect that we can actually change the amount of CO2 through severe regulation or whatever, cap and trade or whatever, what percentage of that human contribution to CO2 could we expect to see without destroying the economy, et cetera, which we've heard rhetoric about? What is the percentage would you expect that we would be able to eliminate? Are we talking about just setting a cap on where it is now? Are we talking about actually decreasing it? How much could we decrease it without hurting our economy? Maybe 10% or 20% of what we are currently contributing? Would that be fair? In other words, are we expecting a 10 to 20% decrease of what we are currently contributing? Would that be something that would not be so catastrophic to our economy that it would damage the standard of living of our people? And then what percentage of that is the percentage that we're talking about in the air? What kind of contribution would that make? I think what we're talking about, Mr. Chairman, is a massive effect on the lives of our people and a minuscule, if not even recordable, impact on the amount of CO2 going into the air. It's very easy to say, oh, the United States puts 20% of the CO2 into the air as if that is a huge impact on the air. But we're now seeing that just represents a very tiny, insignificant part of what's going on this planet in terms of air. Were there other times before humankind even existed when the CO2 was a lot higher than that? How much higher was it in the past, even before human beings existed?
Congressman, in the last several 100,000 years, we're well above what we were in very ancient times. Say 100 million years ago, there were higher amounts than there are now.
Okay, right. And in terms of the history of the planet, we're talking about the last 5,000 years as being, a very minuscule part of the history of the planet. In the history of the planet, there have been times when, you say 100 million years ago, what level of CO2 was in the air at that time?
Congressman, in ancient history, like 100 million years ago, there was significantly higher than there is now.
Right. I've heard, perhaps 4 or 5 times the amount, maybe even 10 times the amount. During that time period, did plants, oh, I'm sorry.
Right.
Could I ask one last question? Did plants and animal life thrive during that time period, or was there some huge problem that plagued humankind so the plants were less abundant and the animals were less healthy? By the way, I'm sorry I used my time. Obviously, the answer is
it's a dangerous thing.
There were abundance of dinosaurs and other animals and an abundance of plant life, and that's why this issue is a threat.
It's a dangerous thing when someone's already exceeded their time limit by 1.5 minutes and they begin to ask you about the Mesozoic era.
Thank you, Mr.
Mr. Bilbray for 5 minutes and eons.
For the record, it was extraterrestrial intervention that eliminated that dinosaur, not the CO level. Okay, so we can agree on that. My question, Mr. MacDonald, is your baseline. You assume that everything above our baseline when we started testing is man-induced, right?
The predominance of the CO2 added is man-induced.
Okay, so that assumption sort of really moves towards the one extreme of an assumption rather than mostly because it's hard to quantify how much of the natural fluctuations going on because we haven't had measurements, right? We don't have a history of measurements prior to the baseline.
We really have quite a good history in the ice cores, Congressman.
Okay. And it's the ice cores that we're looking at. I'm just looking at 2 issues that really kind of frustrate me with our policy is that we keep talking about the 28% of mobile sources and developing technology to address those, as the chairman pointed out, at the same time that we have the technology to eliminate 38% of just the stationary sources. At the same time, I guess, what is it, black fuel they're talking about, Mr. Chairman, trying to eliminate the credit for
it? They've already kept it out of the bill. The current bill would say that forest biomass from federal forests does not count towards renewable fuel.
And the term black fuel, or whatever they call it?
Well, that's it could be that. Depends on how you process it.
That's one of the things.
Yeah.
But it's that kind of winners and losers we get into rather than looking at outcome. One of the things that I really encourage with your science, and let me just tell you this from practical knowledge, a huge mistake we made in California was assuming that our modeling, that our original assumptions were right. We were operating off of tailpipe emissions when we were working on automobile industry, and I think you agree, we're light years ahead of a lot of other people. I think there's over 1/3 of the states are following our new emission standards. But one of the things that really helped us get back on track that we were totally off, that the so-called experts were dead wrong about, was we grossly underestimated evaporative emissions with automobiles. And the only reason why we were able to detect that failure is that we had remote sensing that detected that our emission reductions did not reflect our modeling standards. That's something that the experts were wrong. And the ability to go back and be able to do a reality check is why your industry or your science is so important. Because so often we love to make these assumptions and not go back to make sure that, as good scientists would, that our assumptions can be proven not just in the laboratory, but in real-world applications. And there was a great example where the evaporative emission issue was so grossly underestimated, it was like 85%, that the air quality was not improving in the LA area basin, even though we had done extraordinary improvements with the tailpipe emissions. And I just like to point that out, Mr. Chairman, because I think a lot of people, I do not want to see us spending millions, if not billions of dollars about arguing the climate change issue. I want us to use that money to research what is and isn't working, where it is working, and continue to talk about the issue of what can be done to reduce it. And I will say it again and again and again. I really resent the fact that this town is into picking winners and losers in this issue rather than going with the good science. And the chairman has been very cooperative with me at being brave enough for us to talk about the outcome is what matters, not who contributed to us and who's supposedly a good guy and who's a bad guy. And that's the frustration I have working again and again on this issue is everybody's looking. The bill that's being proposed on this floor, as pointed out by the chairman, is picking winners and losers based on some assumption that to me does not reflect the science that you've presented to us on a lot of things, and other scientists have presented to us. And what I hate is it's being done under the guise of science, under the guise of saving the planet. And frankly, I'll use the term, I'm sick of a town full of environmental Jimmy Swaggarts who wrap themselves in green blankets and claim that God demands that we give their money to them because they will save the earth, when in fact the science doesn't reflect that. And I think a lot of us got to be brave enough. And the challenge to you as scientists, being willing to stand up and say what is not politically correct at the moment or acceptable among certain groups, being able to say, here's the science, and that science leads me to an assumption that the system or those who are trying to say they are addressing the problem are not working with that. And I appreciate the chance to jump into this again, Mr. Chairman, but I just think we got to stand up and say the emperor has no clothes on this issue. This is a crisis we need to address. We need to address it with real answers, not manufactured ones that reflect some agenda that's been sitting around for 30 years. Thank you, Mr. Chairman.
Thank you, Mr. Bobright. I think at this point we'll thank our witnesses and thank those others in attendance, thank the colleagues on the panel, and I appreciate very much your insightful and informative testimony. The hearing will stand adjourned. Thank you very much.
Sorry, I don't know. Yes.
I neglected to mention the record will be open for the traditional 2 weeks for if people have additional comments. Thank you.